Hello everyone, this is Riley, and today I want to talk about Gödel's Incompleteness Theorem. This theorem deals with the foundation of mathematics, equations where our mathematical system is complete or consistent, and the answer is surprisingly no. And when the paper of Gödel's came out in the 1940s, it shocked basically the whole math field because, people were shocked to know that the system is not complete, meaning that there are true statements out there that cannot be proven using only our axioms of such systems, like our assumptions of the systems. So, how did this question arise? In the very beginning, math was discovered to describe nature, essentially, like Euclidean geometry. Its axioms, it aligns with our reality, kind of, at least its goal was. And later on, there was not only Euclidean geometry, there was hyperbolic and elliptic geometry, which is not exactly a reflection of our reality. It becomes more abstract, more and more abstract. And so math becomes this kind of system, which you have this set of axioms and assumptions, and through formalized logical steps, you can get to another place. And that's what the process of proof and I think most of modern math is about. I heard an interview before talking about proofs like an equation where there is an input, the axioms, and the output, the things you want to prove. A job as a mathematician to find the proof is to find such equation that has an input of these sets of axioms and gives an output of the desired solution and proof. So this is a state of modern mathematics, and in the early 1900s, Hilbert came up with a program which he hoped to formalize all mathematics in an axiomatic form, and together with the proof that this axiomatic system of math is complete and consistent. So this was his dream. It never actually happened, but it did inspire Gödel to actually disprove this program and say that this program is not possible. Hilbert did come up with it that helped Gödel's proof is to separate the idea of mathematics and meta-mathematics. Mathematics are symbols. They are formalized symbols, like, for example, 3 plus 2 equals 5. That's mathematics. But meta-mathematics is a description of those symbols, like the meaning that we give to those symbols. For example, 2 plus 3 equals 5 is an addition equation. Like, this statement is a mathematical statement because you're trying to describe those symbols, if you get what I mean. This idea was largely used in Gödel's proof later on when he's trying to prove. So what exactly did Gödel prove? His incompleteness theorem has two parts to it. First part is he stated any system which arithmetic can be developed, it's essentially incomplete, meaning there are the number theoretical statement that cannot be derived from the system, even when the number theoretical system is true. So basically, like I said earlier, there are statements out there that are true within our system, but cannot be proven using only the axioms of our system. And the second incompleteness theorem is even if the system is consistent, it is impossible to give a meta-mathematical proof of the consistency of this theorem. So basically saying that you cannot prove the consistency of the theorem of the system using only the axioms of the system. So each system cannot be like, oh, I'm consistent. You cannot prove that. So, like, for example, you cannot lift yourself with a bag. If you put yourself in a bag, you can't lift a bag. That's more of a physics. That's how I imagine this proof is kind of like. So, for example, people were trying to prove that our system, our arithmetical system, is consistent by mapping it into for example, hyperbolic geometry system. So if you map 1-to-1 and 1-to-1 corresponding mapping to those two systems, if one of the system is consistent, then the other one is also consistent. But you cannot prove neither is consistent because neither can't prove itself being consistent. You see, it's very interesting. And that's what people were trying to do way before Gödel, before Hilbert, when they were trying to prove that the system is consistent. So how exactly did Gödel prove his incompleteness theorem? He used an ingenious form of mapping where all arithmetical statements, like all the symbols and all the meta-mathematical statements, are mapped a one-to-one correspondence to Gödel's number. So he developed this whole like his own systems of numbers such that every mathematical statement can be converted into a string of positive integer numbers, and he completely arithmetized the formal system. So through that he showed that his system is incomplete, and thus our mathematical system is also incomplete. His actual paper is a lot longer than what I just said. It's a lot more complicated trying to convert everything to Gödel's number, and it's a lot more logically rigorous to understand his proof. And I hope this was mind-blowing and eye-widening to hear. And thank you for watching. See you next time.